In this question, we are talking about approximating the solution. Of course, this question comes under approximating the solutions using Euler's method. And this is only for those who are taking calculus BC. So the question talks about let y equals to f of x be the solution to the differential equation. And the differential equation is given here. And also the initial condition is given. So this means when x is 1, the y coordinate is 2. What is the approximation for f of 0 obtained by using Euler's method with two-step length starting at x equals to 1? So now we need to, so right now we have x equals to 1 and we need to get what is x equals to 0 in two steps. So that means each step I need to go back by 0.5 units. So that's why here the step length would be negative 0.5. It is not going to be positive 0.5 because if it is a positive 0.5, I will end up in finding out what is f of 2. So here the step length, so that's basically the change in x. So step length or change in x, or you can also sometimes we also represent it with h. So it's going to be negative 0.5. And we need to do two steps to get the answer. So in order to do this, the first thing that we should be aware of is, so whenever we talk about xn or maybe xn plus 1, so xn plus 1 is nothing but xn plus change in x, and yn plus 1 would be yn plus change in y. And this one still remains the same thing, xn plus change in x, we know it as 0.5, negative 0.5, we can write it like this. And yn plus 1 would be yn plus, now change in y. So you need to know this, change in y over change in x is same as dy by dx. So in that case, change in y, we can also say it as dy by dx multiplied by change in x. So now, in that case, so change in y can be written as dy by dx. So that's nothing but 2y minus x. This is what is dy by dx multiplied by change in x. So the change in x is nothing but negative 0.5. And this is what will be y of n plus 1. And this is x of n plus 1. Now, I'm just going to kind of make it like a table thing. So n plus 1, x of n plus 1, and y of n plus 1. So when I take n plus 1 as 0, so I'll be getting something like x0. So that's the initial value, which is 1, y0, which is 2. And when I take n plus 1 to be 1, so that's basically x1, which is nothing but x0, which is 1, minus 0.5, so which is nothing but just 0.5. And y1 has to be equals to y0, so which is 2 plus, and for these x and y values, we need to use the previous value. So that's going to be 2 times 2 minus 1 multiplied by minus 0.5. So if I simplify this, this is going to be 2, and this is nothing but 4 minus 1, 3, and 3, and this one I can also write it as minus half. 3 multiplied by minus half has to be minus 3 by 2. So which is going to give me the answer as just positive half. So that clearly tells me that when x is 0.5, y is positive half. And when I put n as, this is the second step and the last step we need to do it. So which is n plus 1 is 2. So that means it's basically x2 is equals to x1, which is 0.5 minus 0.5. So that means it's 0. So when x2 is 0, so we need to figure out what is y2. So y2 is nothing but the previous value, which is half. Then plus 2 times the y value, which is half. Then minus x. X also we have it as just half, and multiplied by minus half. So this is nothing but half, and 2 will get cancelled out. 1 minus half is just half, and half times minus half would be minus 1/4, and half minus 1/4 is just 1/4. So this will be the answer. So when x2 is 0, y2 is 1/4, and that exactly matches with option C. So that's why option C is the right answer for the sum.